convene the Board of Directors meeting for Beacon for Friday, January 24th. Could we also have Director Brennan call to order and have a roll call?
That's right, good.
There we go.
Happy 2020 and the first Beacon meeting. Appreciate you all being here, and it's a fairly aggressive agenda, so we appreciate your patience and interaction today. Let me start with the roll call. Member Bennett.
Here.
Member Zaragoza. Member Galma.
Here.
Thank you. Member Ramirez. Member Weir.
Here.
Member Shaw.
Here.
Member Richards.
Here.
Member Williams.
Here.
Member Hart.
Here.
Chair, we have a quorum,
Great,
7
thank
members. We did have 3 other members acknowledge that they were not going to be able to join us this morning, so we can proceed. I did want to say that because of the nature of the information, having the USGS come down, and all the presenters, that I am having it taped, and it'll be on the Beacon website for the 3 members that aren't here and for the public to catch up on exactly what's going on. So we just start with that. I did want to say that the agenda looks a little different. First of all, there's a fair bit on there, but also just the layout. I asked Mr. Baylor to work with me on sort of getting the agenda to a point where, as you can see, a little bit more administrative items and initially, and then the Beacon meeting agenda organization, and then basically we're sort of reformatting it a little bit. And as we go through the year, you'll find that we'll be having the public will be having presentations from different bodies, but the presentations will come at the beginning of the meeting. And for lots of reasons, other than if folks want to leave because we're doing our business or just administrative things, the idea we can get the presentations, have questions both from the board and the public to be part of that, and then we'll do our best to archive and videotape those also, so they'll be available for folks. So at this point, I just wanted to give you a quick, you'll see that it's in the staff report, it lays out what we're going to be doing over the next year in that regard. So there'll be sort of focused meetings. Like today, it's going to be the sediments in the system and who's managing it and where's it going and how much we can expect. And then over the next few months, meetings, we'll be having presentations from both the city of Santa Barbara, the county of Santa Barbara, and even updates from the county of Ventura on their sea level rise adaptation plans and all the things that are starting to hit the radar screens come front and center. So the public will be able to get educated on that and be part of that also. So that being said, Mr. Chair, we can move to item C of the administrative items, and that's approval of the agenda and filing of the certificate.
All right, just before we go on to that item, let's see if there's any questions about the upcoming topics that were described in B about the calendar. Those sounds like a great way to organize the year and to give us a heads up as to what's coming in advance. Anybody want to weigh in on any of those items? If
Right.
that's a
I
thumbs
did
up,
want to say,
that's all we need.
Mr. Baylor was looking from 30,000 feet back in and drilling down, saying, hey, this would be a great plan. And so it is a bit of a change on the format for you as you look through it, but I think it's very timely and as both for the public and for ourselves as a body to be aware of what's coming up next year.
Can we have a motion to approve the agenda and the filing of certificate of agenda posting?
So moved. Second.
Motion's been made by Director Shaw and seconded by Director Weir. All those in favor say aye.
Aye.
Oppose and abstain. Matter carries unanimously. On to the Beacon minutes. Has everybody had a chance to look at the minutes of the November 15th meeting? And is there any corrections or changes? Director Richards?
A slight correction under my report. It says here that I reported that the State Land Commission had decommissioned platform Holly. It should read that they're in the process of decommissioning platform Holly.
Okay. With that change, would you make a motion to approve the minutes?
I would love to.
And is there a second? Motion's been made by Director Richards and seconded by Director Shaw. All those in favor say aye.
Aye.
Oppose and abstain. Matter carries unanimously. Next item is public comment for matters that are not on our agenda. Would anyone in the public like to speak to this item? Yes, sir. Please come up and give us your name.
My name is Dennis Chenoweth. I'm the president of the Solomar Beach Colony Homeowners Association. My purpose in stopping by this morning is to inform you about some changes that are occurring in our beach area and to ask for your support and assistance as we move forward here in the future with this. By way of background, some of you know that there is what is called the Grub 5 lease that exists between Faria and Solomar. For those of you who drive down PCH, you'll see a concrete vault surrounded by chain link fence. That's a pumping station for CRC in the oil fields. That pumping station also has 3 outflow-inflow lines that stretch out into the bay over 600 feet. We've been notified by state lands that the lease has expired, and CRC has been asked to remove those pipelines and to remove the pump station. This is important to us because we believe that the pipeline and the pump station create sand retention along the beaches in the Solomar area on down to Emerwood State Park. We're concerned that when the pump system is removed and pipes are removed, that the unintended consequence of that action will be a change of the deposition of the sand along that stretch. Our concern is kind of predicated on the earlier example that took place when they decommissioned oil piers. Yep. And if any of you are familiar with oil piers, you'll know that all of the sand washed out of there. Nobody surfs there anymore. The only thing that protects the road is rock revetment. So we are concerned that the beaches that protect PCH and the infrastructure of PCH, beaches that protect our homes and provide recreation for the public year-round will disappear. The actions that we're really asking for first is, that's our supposition based on prior examples. We'd like to understand it better, and it's possible that people associated with this group can give us a better understanding of what might happen. And the fact the second item on the agenda, or the third item on the agenda, gives me some hope that that will happen. The other thing that we'd like to ask is that this provides an opportunity to collect data and to really understand what happens when these structures along that area in the coast are removed. So I wanted to make you aware of it and see if that's something that would be important for you to collect data, understand, and in the future not to have these unintended consequences that we fear. And the final act that I'd really ask is that now that you're aware of it, you understand our concerns, we'd ask your assistance and help to with the current situation and going forward. Our request really with CRC would be, and to the State Lands Commission, don't change anything. Take the pumps and the stuff out of that vault and change that, fill that and change that into a parking and area along that area of the coast, which is pretty well used and can be overused during the summer. So I appreciate that. Thank you.
Thank you, Mr. Chenoweth, for bringing that to our attention.
Mr. Chair?
Maybe, yes, Director Bennett.
I'm sorry. I just wanted to point out this highlights when we were taking out oil piers, and I know some of us that were here remember we had lots of conversations about trying to put in an artificial reef there, et cetera. And so this highlights the value of Beacon. There is a place for the homeowners to come to and a place for the various government agencies to say, hey, what kind of expertise can Beacon bring to analyzing this, but also what kind of creative ideas might we be able to come up with in terms of addressing the potential loss of sand that would be associated with this. But with climate change and sea level rise, we're all going to have to be creative about how we handle erosion and changes at the beach. And so this is certainly the appropriate body to have these conversations with, and it's too bad we couldn't pull off the artificial reef at oil piers after a lot of investigation, but those kind of things are worth us continuing to look at. So thanks for calling this to our
One
attention.
additional comment about that. In the Ventura County Planning Department's sea level rise plan that they're putting together. In the draft report, they note that that area along PCH really is a critical connection between Santa Barbara County, Ventura County, the railroads are in there, all of the infrastructure is in that section. And they cite in their executive summary that it could be an important area to put in artificial reefs and groins to help retain sand and to protect that particular portion of the coast, which is quite unique and maybe only mimicked by what's happening down in Del Mar. So, thanks.
Thank you very much. Perhaps our staff can look into this a little bit more, and then if there is something to bring back as a future agenda item, we'd appreciate
Thank you,
that.
Mr. Chair. I know Mr. Chenoweth forwarded a letter to the county, and we've seen it in that capacity. Certainly, we can use it and see if there's a letter of recommendation we can bring to the board after following up and doing a little research on that. We'd be happy to continue the input. I do say anything that's holding sand presently, you almost don't want to see it go away. Whether I know in the case of some of the oil infrastructure, a lot of things were put. When it's not used anymore, it needs to be taken out. And I don't know if that's even in the lease, because it might even be prior to the Coastal Act. I'm not sure, but we certainly will look into that and then bring it back to the board accordingly.
Thank you. Are there any other members of the public? Oh, excuse me, Director Gamma.
I just wanted to make the comparison that if we toured Point Magoo recently, and going back when I was a child, the rock revetments hadn't even begun to be constructed when we were there. 4 truckloads of rock came in to solidify and strengthen the existing rock revetment. And then if we can't reverse what's going on there, the rock revetment is just going to continue on all the way to Hueneme Beach. And that's what you have here. You have a rock revetment that can't hold the sand. And so hopefully we could just keep that in mind as we try to realize a way to hold sediment in place. And we certainly have figured out how to move it on.
Are there any other members of the public who'd like to speak to any item not on our agenda at this point? Okay, then we'll go on to item number 3. One of the presentations, the annual USGS Littoral Cell Briefing from a hodgepodge of acronyms, including the Santa Barbara Channel and Beacon member agency reports on sediment management activities.
Mr. Chair, I think we'll introduce Mr. Dan Hoover again with the U.S. Geological Service. We're very fortunate to be able to have the USGS working in the Santa Barbara Ventura Bight, so to speak, and very, very actively over the years, lots of years of study of sand and sediments coming up and down the coast. And we were fortunate about 18 months ago to have Mr. Hoover give us an update, and we thought it'd be appropriate not only just for this January, but once a year to start on that, because things and questions are going to be even asked. I know we have members of the public here that are interested in that, both homeowners along the coast to understand a little bit better, and whether the coastline is presently accreting or growing, or is it we know it's always eroding, but can the accretion outsee some of the erosion presently? So we also have on the agenda a brief presentation from the County of Santa Barbara, flood control, and any expectations of possibly if there's going to be debris or basically sediments coming to the ocean. We also have Matt Roberts, a great host here from Carpinteria, talking a little bit about Ash Street and what their plans are. And then moving further down the coast, we have Susie Watkins, who's with the County of Ventura, the Harbor Department, who oversees the dredging of the sand that gets moved around the corner to the city of Port Hueneme. And then we have actually the Port of Hueneme, who's here to give us a little update on some of the projects they're going to have about putting sand and sediments into the ocean. And hopefully, and being in the nearshore environment, that'll benefit the beaches, and especially hope we want to, after the tour of the Naval Base, is how it might affect them also. So, Mr. Hoover, thanks for your presence. Welcome, and thank you for taking the time to come down from Oakland.
Yeah, glad to be here. It's always fun to talk about our stuff with people who are actually interested. I'm going to focus today on the flood impacts. That's what Brian and I talked about a little bit. I was here July 2018 after the January floods. Talked a little bit about what we had. I won't repeat a lot of that, but I will show some slides that add on to some of that. This picture there in the
Go to
front
Dennis
is
this
the survey we
afternoon,
did
too.
right after the floods. It's a beautiful day at Butterfly Beach. No evidence of all the mud that came down Olive Mill Road and inundated the area. So this is where we work. We work all the way from Goleta down to Point Mugu here. I am going to talk to you, like I said, mostly about the Montecito area and the flood impacts there, but also because that storm was kind of focused in this area, in the Montecito and Carpinteria area. Goleta didn't get as hit as much. There wasn't as much down in the Ventura area. I will talk a little bit about those areas, but I'll focus mostly on the Montecito area. I will talk also at the end about the 2 nourishment projects that go on, because we do some monitoring in those areas, as Matt's going to talk about, off Ash Avenue in Carpinteria and up at Goleta Beach. And then at the very end, I'll touch briefly on the beacon stuff that we're doing and some updates there. So some overview stuff. You've seen part of this slide before, everything outside the circles. This is the long term for the duration of when we've been surveying changes in the beaches in several areas. Santa Barbara here is the green line up here. You can see the big wave event in 2014 that knocked things down here. Since then, the region has kind of been declining. The beaches have been eroding a little bit. I'll show a breakout in a second that shows some more information on that. But you can see comparatively up at Ocean Beach where we surveyed, we've had a lot of accretion, big erosion last winter, 2 winters ago. You know, some here, not so much. This is the anomaly down here. This is how much erosion we had in a given winter compared to the average of all the winters that we have. Pretty average every place except up where we're up in Ocean Beach. Pretty typical at the other sites. This down here is the wave buoy data. The erosion depends on the waves. Pretty normal waves. This is the wave anomaly here. The previous winter, the waves were really low, so we didn't see as much erosion as we might normally. Back here in 2015, 2016, the El Nino winter, we saw big waves, lots of erosion. And I think what I'll do is I won't go through all the details in the slides because you guys will glaze over probably, but I'll leave the information there and hopefully you'll have a chance to look at them later if you want details out of them. This is the breakout for the Santa Barbara area, for the areas we look at. So I'll talk about things by Goleta, Carpinteria, North Ventura, which is the San Buenaventura stretch, and South Ventura, which is the area down by the Santa Clara River mouth and the power plant. You can see that what's dominating the signal here in terms of erosion is the South Ventura. This is the stuff down off the old Santa Clara Delta, which built out here after the record flood in 2005 and has been declining ever since. Now, it had kind of stabilized in here. It started to drop again in the El Nino year, and it has started to take off again, and we're not sure exactly why that is, but that's what's controlling the overall regional signal. There's been a little bit of accretion up here in Carpinteria. We'll talk about that a little more in the future, and Matt may have something to say about that too. This again is the erosion anomaly here, big erosion anomaly for South Ventura. Pretty normal for the other areas, and pretty mild winter again for the waves in here. All right, so a little bit of setting for this. I don't know how much you guys think about sediment transport in the area, but I wanted to highlight this, that most of the sediment transport is from west to east through here because most of the wave activity is coming in from the west and northwest swells. And as you guys all know, it's beautiful in here. The waves are usually very small because we've got this channel action coming in here that diminishes the wave height as you move down the channel. There is a section down here at the end where we're exposed to south swell. We can actually get some transport to the north in that area. This was some modeling work that was done that shows that as you move along the coast, and I've tagged it here with all the areas that we're interested in. Montecito, interesting, is right in here in this point where we actually have a potential sediment reversal. There's very little sediment transport along the coast by the time you get to Montecito. Now, this depends specifically on the wave event at Ventura Harbor and up at Santa Barbara Harbor. But this is a major feature here that you get movement along the coast this direction, so you get to the Montecito area, then it pretty much stops in there, and then it picks up again as you move past, but it also moves north and south. You get these big negative events here when you get big south swells coming up on the Santa Clara River Delta. This is the actual wave cases, the 2 main wave cases that drive that. This is your sort of typical west-northwest swell coming down the channel. You can see the size diminishing as you move in. By the time you get back in here to Montecito, there's pretty much no waves left. It's not a big surfing area. But as you come over here in the south, you can get pretty big waves up here along the Mugu area and up into past Ventura and a little bit to the north of there. All right, now you're going to see 2 types of things. I'm going to walk you through, this is the Montecito, this is where the big mud flows were in here, up in this area. We put lines all through this stretch here so we could connect it to the Carpinteria stuff that starts down here. And I'm going to walk you through the individual stream mounts that are tagged up here, areas where we might expect to see inputs. And this is what you should expect to see. For a seasonal change, in the wintertime, sand gets pulled off the beaches and moved off into bars like this green profile here. This is from our Ocean Beach site. And in the summertime, it should migrate back up on the beach and create a pretty smooth profile. So what you tend to see in the subtidal stuff, which is mostly what I'm going to show, the bathymetry, is you see offshore movement in the spring, onshore movement in the fall. So that's not storm inputs. What we want to see for storm inputs is stuff below there that's creating bulges or makes these move in the wrong direction. All right, now just starting, and I'm going to go fairly fast through these because there's a fair number of them. This is off Olive Mill Road where that first picture was. We did this. There's no direct stream input there, but there was a lot of inundation there around the Biltmore. There's no obvious evidence of any kind of input here. It's hard to see here because it's rocky. This bumpiness is rocks. So it's hard to tell. There might be something down here, but nothing that we can really tag a volume to. Now we start to move east. Now we're up here at Montecito Creek. We actually have a bulge. There's some sediment. So that red line is the spring survey. These lines, most of them, we don't have a prior survey in 2017 because these were all new. There are some places in the littoral cell where we do. So what we're looking for is diminishing here, and we see this little bulge diminishing over time, going back to this black line, which was the fall 2019 survey, which is a pretty smooth curve. There might still be a little volume in there left, but mostly that's been moved away by waves. Moving further to the east, seasonal stuff up here, maybe something down here, not a ton. I've tagged these with some volume estimates down here to add up as we go along. That is what Oak Creek looked like when I was there. This has a mud layer on the beach with footprints in it, so you know stuff came out there. One of the issues with the mud flows is there was a lot of mud in them. Mud tends to disperse rapidly. It doesn't tend to settle out on the bottom. Now, I'm sure there was sand in there, too, and we know there were boulders. We see boulders on the beach in some of these areas. I'll show some pictures of that. But we're not sure how much sand came in, so that's what we were looking for here. Further over San Isidro Creek, right next door, maybe some stuff down here along the base. You know, no big bulge like we might have expected from a massive input. Romero Creek, here we start to see the seasonal stuff up top, a bulge here, and then it's filling in down here as it goes deeper. Now this is down at 6 meters. That's fairly deep for the waves that are out here. You don't normally expect sediment to move in deep water when you don't have big waves to move it. So in these areas where if you see a 2-meter wave, 6, 7 feet, that's a pretty big wave for these areas. You don't normally see sediment moving around below 2 or 3 meters. So this probably is a little bit of deposit filling in here from there, but we're not going to see a lot of movement down low here. Moving along further, this is downdrift from Romero Creek. Pretty big changes up near the surface in here, not so much down below, maybe a little filling in down here with this black line. That's higher, and we can actually resolve these kind of differences with the jet ski system that we have. If the profile is the same shape, I can't tell you for sure that a 10 centimeter difference is real, but if the profile is changing shape as it's flattening here with the underlying curved one, I'm pretty sure that's real, especially the way it dips down here and touches that low red line. Further along now, I will say we saw nothing in here. This is big seasonal change in here. You got good sand beaches in here, but you can't really resolve anything here. You get to the point where there's an input here. We saw rocks on the beach here, new rocks on the beach here, but we don't see a lot of evidence in the profile of sediment input there. Now that may be because this is a prominent point, so waves coming in from the west hit this point, energetic, the most turbulence is there. This stuff gets pushed around the corner, so this little downdrift line here that's dashed does show maybe a little bit of elevation in there. This is our poster child for sediment input. We're all the way down at Arroyo Paradon here. Nice sandy beach here along Santa Claus Lane. You see big seasonal cycles up in the top and the other profiles, but down here, pretty deep, 4 to 6 meters, we see a pretty good bulge. Now it's clear in the profile, but it's not a ton of volume. We've got about 2,000 cubic meters there, and there's nothing on the line on either side. That's what it looked like when we were there for the spring survey. All right, so $1 million question, why aren't we seeing a lot of sediment? One, it may have moved. Here's the wave record immediately after the storm. Here's where the mud flow inputs were here in a local newspaper article. Here's when the storm was. There was some big waves associated with the storm. Not super long period. The period is down here. It was long enough that there was some energy. Direction's pretty standard. The buoy outside the channel, the wave direction is around 290 degrees. By the time it gets in the channel, it's about 270. It's due west. Stays the same all the way through this. But there was about 10 days later a pretty big event You know, this was what I think it gets up to 3 meters there. And that's at the buoy that's about halfway in the channel. That means there was some pretty good energy there. So there's a pretty good chance that the stuff that was deposited on the creek mouths, which tend to be prominent points, was redistributed to some degree. Now, that can make it hard for us to see because once it thins out, we get down below about 10 centimeters, which is about 4 inches. It's hard for us to really resolve that in the jet skis. So there is some input here. My best estimate of what I can pull out of the profiles is about 22,000 cubic meters. Not a lot of material. The take-home message is most of this material stayed on land, as we'll be hearing from Public Works later, I'm sure. Most of that got trucked away to the landfill. Some of it ended up on Carpentry and Goleta beaches. But what happened here, I think, is that we had these massive flows. Most of it went over banks and went into people's neighborhoods, went onto Highway 101, and very little of it came out of the stream mouths. Now, depending on your point of view, that can be good or bad, but from the literal cell point of view, it's not good. Because this material that this is a natural event, should have worked its way down to the ocean, stayed mostly on land and ended up in landfills instead of going out to participate in nourishing the beaches in this area. All right, now where did we see some flood deposits? Carpentria Creek really came up during this event. These profiles out here, here's Carpentria Creek, Linden Avenue is up over here. We saw a big bulge of sediment out there. So the green line, the light blue line here is actually the 2017 profile before the storm. So even up here, these lines are 200, 400 meters away from the line of the stream mouth. We saw smooth deposition up here, material well to the north there. Right in the middle and down here, we saw pretty prominent material addition in there. So that looks like about 145,000 cubic meters, and that's probably less than what was there, because this end of the beach down here starts to get exposed to wave attack down by tar pits. There's pretty good waves. When we do the jet ski surveys, we get down in here, we start to get careful because the waves get big in here. So there probably was some erosion off of this side of this that moved some material out of this and down around the point. That's what the beach looked like with all the material on it a couple days after the flood. Okay, other points further south. Rincon Creek. Definitely saw boulders on the beach that people in the lineup were complaining about, a hazard at high tide when they're surfing. Not a lot of evidence in the bathymetric profiles of deep deposits in here, which surprised me a little bit, given the location of this coming out off this point, and we looked at all these lines here. The one shown here you don't see a lot. What we do see is changes in the mean high water contour here, the shoreline. So at Rincon, it looks like the sand here came out, whatever there was, stayed shallow for the most part, and has been moving along the beach. In fact, the profile, when I sent somebody out to do this survey in, I think it was fall of 2018, they asked how far they should walk, because we use a walking backpack to do this. And I said, well, walk until the beach pinches out along the rocks over here, because usually it does. He ended up walking well off of this image over here. And it doesn't show on this mean high water contour, but if I had the mean sea level contours lower, you would see there was sand out there. And you can see a bulge in this blue line here, where this bulge here in the spring profile, the sand that moved over here, had pushed down and bulged out here and is working its way down through here. So I don't have a volume estimate for that, but we certainly saw some material in there. And we have anecdotal information from our colleagues from Dave Hubbard that this area saw some inputs from some storm culverts further south as well. Now, I'll talk about the Ventura River briefly because we had some floods there in January, February of 2019. This is not the 2018 flood, but there's the Matilaha Dam work going on there, and we were supporting them. So we did some extra survey work in there, looking to see if we could see inputs from the Ventura River out here. We pretty much didn't see anything. So even though it was a pretty decent flood, the amount of sand that moved out into the system we could detect was basically nil. Maybe a tiny amount here in this one profile here over in the corner. Now, this may be acting like Rincon. The sand may be coming out and moving along the shallows there because it is an energetic wave environment, so it may not have pushed out deep. We also may not be able to see it well. You know, these points are made up of cobble, so if it's filling in the gaps in the cobble and I can't see it as an elevation change, then it may be there and I can't see it. But it could be working its way around the point here and headed over toward the beach and the pier here. If so, maybe we'll see it in the next year or two. All right, now just to circle back to this Montecito issue and the sediment inputs, that was a pretty big event. I don't know where it ranks in terms of size compared to other flood events, but it's certainly not alone. This is from Santa Clara River Delta data, Santa Clara River data. This was the record 2005 flood. This was put together by Patrick. And if you go back, you know, there are plenty of other big floods, big events. You guys know that. This is from 25 years ago, the 1995 flood. There's a ton of images from that of Santa Barbara being devastated by this flood. So this area lives in an environment where you have very infrequent but very intense rain events. I think I talked last time about how that may get worse. You know, with climate change, more wildfires, more erosion, less frequent but more intense rain events. So this type of input may be the norm. And the type of input we saw in Montecito may also be the norm if we don't find a way to get that material down into the ocean. If it all stays on land, it's going to create a lot of havoc, and it's not going to do a lot for the beaches. All right, now just spend a couple minutes talking about the nourishment areas because we do a lot of surveying in there. We've added lines in there to monitor that. At Goleta Beach, some of this material from Montecito got dumped on the beach over there. Down at this end, we see a nice sediment bulge in there, and this black line is the mean high water contour there. It's built out about 50 meters. This is from 2019 to 2017, so this is the 2-year difference that includes 2 deposition events in the spring of 2018 and the spring of 2019. So we see about 35,000 cubic meters in there, 26,000 underwater, 9,000 on the beach. And this, and I'll mention this for Carpinteria too, they both have cobble under the sand. If you go out here in the wintertime, I was here in the Christmas, passing through in Christmas, you can see these nice little cobble kind of reef formations, cusps coming out here off the beach. So if you go down here, we actually often walk survey this section because you can't drive the ATV very well over cobble. Carpinteria, similar thing, a little different in that this is where they put the material, but we don't see a big bulge here as much. We see this distributed well across the beach. I'll have to ask Matt whether that's because it's actually moving or because they're pushing it with the bulldozers. But there's a lot of volume in here, about 80,000 cubic meters in here now that wasn't there before. And you see this is I stuck these in here because when you go there in the fall and you look at it, the beach looks exactly the same because they level it. Now you go there when I was here over Christmas and you've got the berm, then you can see the cobble exposed down here. And that'll stabilize the beach. You know, you'll erode the sand off that, but you get down to the cobble, it's not going to move very fast. All right, now just a couple minutes on the Cosmos stuff, which we talked about before, primarily because we've got a new thing coming. We're adding a groundwater component to that for the shallow coastal groundwater that gets pushed up as sea level rises, so areas that are low-lying that have groundwater under them that's in contact with sea level may start to get mushy and may actually get flooded in certain circumstances. We're working on that data now, and that's going to come out hopefully in a couple months. You guys have mostly seen all this stuff before. This is the web data for this area is completely updated with all of the shoreline change and the cliff erosion components added in. And for those of you who don't know, there's a couple new people here. We have sort of tagged the areas that are most vulnerable to the inundation component of this as Carpinteria, not surprisingly, around the marsh, and to the south here, around this area in Santa Barbara, and then these areas in Goleta. And then we do provide also with this socioeconomic impacts. We have a whole component of this that takes those impacts and then computes several metrics of socioeconomic impact of those things. And those things are all available online.
Thank you, Mr. Hoover. That was quick and comprehensive, so I appreciate it. Questions from directors? Yes, Director Grama.
That's a hypothetical, kind of difficult, but with the mudslide of Montecito a couple of years ago, if there was no freeway, no blockage to all that material making it to the beach and then distributed naturally, how would that look in what you just showed us? Would we see a big bulge? Because that was a major event that appears to have been cut off, collected in the trucks, and taken away.
I think you'd see a ton. I think the way to think about it is when you look at the coastline, you look at these stream mouths, they almost all are, they extend beyond the shoreline. And that's because those stream mouths, if you look at Rincon or you look at Oak Creek, these things, underlying those is the large cobble and the large rocks that got washed down in historic events, geologic historic events. So you look at Ventura Point. I mean, that is built out. That is not a feature of the underlying geology. That's a feature of the large material that was carried down the river in historic floods. So if you stop that stuff, eventually those features would go away. Now, I don't think that all of it would have ended up in the ocean. A lot of it would have gone over the banks and ended up in the natural environment. But a lot more of it would have gone into the ocean. How much so, I can't see. In fact, I don't have the volumes for how much material was trucked away. You could do some back-of-the-envelope calculations for figuring out what fraction of that you think might have gone to the ocean, how much of that was sand, and that's what we probably should have seen. The typical, the average amount of along-shore transport that we talk about for this area is on the order of 500,000 to 1 million cubic yards a year of material moving past the harbors, and that's how we estimate it from the harbor dredging estimates. So if we saw at about 150,000, maybe 200,000 cubic meters total from the pieces that I can put together in here that came out, it needs to be probably a couple million cubic meters to maintain that long-term average of 500,000 or so with this sparse intermittent events. So we should have seen at least an order of magnitude more material probably coming out of those creek mouths for it to behave quote unquote naturally. Now, this stuff, what we have in terms of records, of harbor dredging records, is based on the system that's already been modified. So we've been limiting sediment input in the system for a long time. What we don't know is how efficiently we're limiting these really big inputs. And this is the first example we've had to go chase it and see. And I was excited to do it. And I was a little disappointed not to see more stuff out there in the water. I was excited to see a big bulge off of Carpinteria Creek. But it does give me pause that we are controlling the system, and we probably will continue to. We don't like floods. We have debris basins. We like to do flood control. But it is going to affect how much material is reaching the coast and then participating in this process that we need to maintain beaches.
Thank you.
Yeah.
Thank you, Director Williams.
Well, I say this partially to help answer your question and also because you do work statewide. We at Santa Barbara County have been convinced by this event to fundamentally alter our debris basin design strategy so as to facilitate the transport of more finer grain sediment, sand and mud, down the watershed instead of trying to detain this. Now, the primary objective of that is simply to maximize the amount of the area of the debris basin that detains rocks, which is the most dangerous of the things that come down. But the secondary advantage of that is the natural transport of sediment down the watershed instead of truck trips that destroy our roads, pollute our air, and are unpopular with residents. And so how that's being facilitated is just with a larger outflow instead of a very small outflow through the debris basins. The designs that we're looking at cut notches into the debris basin that are similar in scale to the current Gubernador Canyon debris basin to facilitate more transport of the smaller materials.
Beacon did get a grant a number of years ago for the retrofit of Gubernador as a demonstration project. And again, speaking to the mission of trying to keep sand, as Dan is saying, we've interrupted sand and sediment stain in the system. So I know you all know it, but for the public here, it is something that we're continually working on, and the county is working on looking at where and when they could retrofit debris basins that would allow sediments to go through and trap the large boulders, rocks, tree trunks, things like that that are causing the damage downstream. And that in itself would help. It's still a deficit. I think Mr. Baylor said over the years about 300,000 to 400,000 cubic yards a year a deficit. But if whatever we can get in from those debris basins will go toward helping the beaches, as you all know. So,
Director Bennett?
I certainly appreciate and welcome Santa Barbara's change and us trying to do that, but I'd like to make sure I understand from your perspective, what's the order of magnitude of, when we make those changes, that sort of takes our normal flows. But these big events, I saw that one statistic there that you had from the Santa Clara River, that in 30 days we equaled 50 years of regular deposit from 30 days of that. What's the impact of having these major storms not making it, not getting the sediment to the beach like they used to relative to the annual sediment deposits. I want to know where the most serious, almost certain the most serious part is the major storms are where we're really getting the sediment transport. Is that an accurate perception?
Yeah, absolutely. It's huge. It's very nonlinear. If you look at a stream flow and you look at the sediment concentration as a function of that stream flow, it doesn't just ramp up linearly, it just goes through the roof. You have to get above a threshold runoff event, and you have to have a confluence of events too. You have to have saturation in the soils, you have to have all these conditions that led up to these catastrophic flows to really move material. It depends a lot on the local geology. The Santa Clara River is a little bit maybe on the high end for the intensity of that because they have a basin within that watershed that has very erodible soils. So it has unusually high sediment loading from that one sub-watershed. But I think that dynamic is typical of this entire region. So the average stuff that we see year to year that we sort of make our decisions based on, our intuition, is really off in terms of the sediment input.
So until we solve that problem of how to make sure that in these major events we're able to get significantly more sediment to the beach, we're going to constantly be fighting a deficit problem here.
Well, and I think you have been. And I think that's the steady state we see now, the condition of the beaches reflects that because we have made these changes already. And the comments that were made about changing the debris basins are really great. I think that will move things in the other direction. Hopefully we will see those changes because what we've been monitoring is a system that has been essentially throttled in terms of those inputs. Thank you.
We are fortunate to have members of the public here that are extremely interested in it, and I was just wondering if they had questions. Having Dan here at the mic now,
Yeah, that's
maybe
fine.
we could just, it's a one time a year, maybe to get that shot. We have homeowners associations and folks here that are property owners. Maybe we could help shed a little light, using Dan's expertise. If there's any questions anybody has, we could be a little informal about it, but if you wanted to pose anything to Dan presently or certainly catch him on the way out, we'd be happy to do that also.
What we're seeing is just the tip of the iceberg and on the beaches, and there's so much more going on somewhere out there that is
There
kind of
is,
resistant.
yeah, there is. The caveat to that is that what you're managing and what you're seeing is the beach. So that, granted, that's tied to the subtidal sand. If there's enough subtidal sand to sort of maintain the equilibrium profile to where you see the beach, then you know things are working over the long term. So if I could, I would get all the offshore data too, but it's much harder to get. And if you can get that beach data that we talked about, whether it's from a drone or from people out there with rods and measuring tapes, that's a pretty good proxy for what's going on in the system. Because that subtidal sand will move up onto the beach if it's within range of that summer kind of creep that comes up. It may take a couple of years to spread out and re-equilibrate, kind of like the Rincon data where you see the bulge moving down the point. But down here where the waves are so small typically, you get down to Ventura, you get a little more size. But west of there, you don't see a lot of sand movement below about 2 meters. And we can't get the jet skis in usually about 1 meter water depth, at high tide is what we can get. And that data starts to get a little shaky because it's rocky and because we're having to turn to avoid things. So that's where the action is, that and on the beach. So I think if you can get the beach, you've got a good chance of getting the story. But it's a tough problem. It's hard to work in these areas, particularly where they happen once every 10 years. And you've got to get out there and get all the data.
I think we had one more question, Mr. Chairman.
Ms. Zimmer?
I'm particularly interested in understanding better for a specific area, in this case, the beach off of Santa Claus Lane going down towards Sand Point. And the question, I've understood this to be an accreting beach over the last 30 years, is what I've been told. Has that been measured through the data you've gathered? And if not, how would one go about finding in the data answers to that question? And then a related question of, if in fact it is an accreting beach or has been over the last decade, how does that relate? You talked about socioeconomic impacts of all of this. How does that relate to the impact of the public's access to the shoreline in a positive or a negative?
Sure. Yeah. Well, you've come to the right place.
Yeah.
You're at the Beacon Board. Beacon started this monitoring program back in 1987, and they have a line right there on Santa Claus Beach. So there are data from those lines starting in 1987. The interval changes a little bit. We picked that program up, I think, in 2008. Since then, we've done it every other year. We just did them the fall of this year. So we actually do a walking survey along that line on the beach, and then we survey the offshore part with the jet ski. So there are data back to then. I have not looked specifically at that area. My sense is that beach is pretty wide. You know, there's a lot of sand there when we go there. I don't know if it has net accreted over that time period, but it'd be easy to find out. The impact side, in general, we believe that wide beaches are better. They have more value, both as a resource and then also as a source of sand to the downstream stuff. Because that sand, by the time you get to Santa Claus Lane,
Yeah.
you're moving out to where the beach is actually pretty exposed to wave attack. The waves get pretty good size there. So you see a lot of seasonal change in those profiles, the sand moving offshore in the wintertime and back onshore in the summer. And when that's stirred up in the wintertime, it's also a net being shifted, sliding down toward Carpinteria. So Carpinteria would love to see that sand, I'm sure. Now there's a little issue down there as you reach Carpinteria because there's a reef right off of the estuary mouth there. There's a very shallow, about a 2-meter sill as you come south there. So we don't see, I don't think, a lot of sand coming from the north entering into the beach at Ash Avenue area, which is partly why they dumped a bunch of sand in there. But yeah, wide beaches are better in almost every respect, I think I can say.
Okay, thank you. Any other questions from members of the public? Thank you, Mr. Hoover, for your presentation. We are adjourned until March 20th. Thank you.